All right, so future value. So a lump sum of $1,000 is invested 4.3% compounded continuously. So that's sort of like the one we had earlier, but now we actually have to write the model. So let's call our model, we want the future value, so future value at time t. I'm probably going to end up changing it to x, but that's okay. And that's going to be, and then here again, we only invested 1,000, so it's going to be 1,000. And remember, it's going to be PERT. So it's going to be 1000 e to the 0.043 times t. Okay, so that's going to be our function. And then we want to write a model for the rate of change. So what we have to do again is what we did last time. We're going to take b is equal to that, plug it in and do that. So we have to find e to the 0.043. And so if we do that, we get 0.043, 1.404, 394. Okay, so that's good enough right now. And then whenever we have that in our equation, when we do the final value, we'll plug in e to the 0.043 instead of that into our equation when we're actually solving it. So b, then we need to find f prime of t. And so that's going to be, well, let's go ahead and write that again as what we were doing before, 1000 times 1.04394, and then to the t, okay? Now, that becomes 1000 ln of 1.04394, and then times 1.03, I can't write what I'm looking at there. 1.04394, and then it's to the t, okay? So that's going to be our function that we use. And what is our units? It's going to be dollars per year. Okay. Now, how much is the investment worth after 5 years? So f prime of 5 equals 1000 ln, and I'm going to put the e as 0.043, and then 0 e to the 0.043 times 5. And then that should give me the value there. So 1000 ln of, okay, and then e to, all right. So that gives me the value 53.31406, and that's dollars per year. Okay, that is what we have. Oh, I'm doing D first, not C. Huh, I read the wrong one. How much is investment worth after 5 years? So let's call that D, and C is just going to be F of 5. So that's just going to be 1000 e to the 0.043 times 5. And so that one is going to be equal to, but anyway, so this one, after we plug all that in, we get this value. And again, we don't have to round on the rates. This one we'll have to round to the penny. So that's going to be 1000 e 1000 e to the 0.043 times 5. And so that gives us 1239.86. Okay. So that one we have to round to the penny. This one we don't have to. And so, yeah, so you have to read which one we're doing. I made my model, then I immediately wanted to find that rate of change after 5 years, where they wanted actual, what is the value after 5 years. So those are the two things we need. And so that's how that one works. And again, the key here was we had to write our function. And then after that, we had to convert it to a function that's exponential that we can actually work with, and not one we have the e to some power times the t, okay? Because we can't do e to the x. All right, so let's stop there and come back for more.